Hello, everyone, and welcome to this webinar. It's really a pleasure to welcome you. So I'm Frédéric Desbiens, and I manage IoT and edge computing programs at the Eclipse Foundation. And today we meet together to learn more about Sparkplug, the next phase of evolution for industrial automation. All right, so very briefly, because you don't want me to hear, so the organizers of this webinar are the Eclipse Foundation and specifically the Sparkplug working group at Eclipse. So the Sparkplug working group essentially is there to foster the evolution of the Sparkplug specification and generate interest in it and obviously drive adoption for it in the market. Our members are, current members are here on this slide. And a big thank you to Canary Labs, Chevron, Cirrus Link Solutions, Inductive Automation, IVMQ, and Opto22, which are our strategic members. And they are joined by Flow Software, Intel, Signalfire, and the University of Sheffield. Coming soon, we'll be coming with details about our new Sparkplug compatibility program. So if you are an implementer of Sparkplug-based solutions, you'll have an opportunity to be featured on our website as an adopter of the technology and certified through the open source TCK that your product is really compatible with the specification. Now, our agenda for today, because essentially we're trying to make the point that Sparkplug is the next step in evolution for industrial automation. But, you know, rather than having me drone for 60 minutes, we have actual people straight from the trenches that will prove that. But first, we'll start with an update on the status of the Sparkplug specification by Wes Johnson, the project lead for the Sparkplug specification project. And after that, we'll have three interesting use cases from our members, one of them being the universal wellpad controller by Intel, a public water use case by Opto22 and their guests, and finally a segment on connecting AWS Sitewise to MQTT by our friends at Cirrus Link. So that's all for me for now, and let's hear from Wes about the state of the Sparkplug specification. Once again, thank you and welcome. So here's Wes.
Hello, everybody.
Yeah, we can hear you. So just have to share your screen, and we'll be good to go.
All right, it's thinking about letting me share. Maybe.
It's not up yet.
So I'm just getting a spinning icon where this share screen button used to be.
Interesting. Worst case, what we can do, send me the link to your slides and I can share them on my side. It seems the gods of Crowdcast are not with us today.
Right. It worked 10 minutes ago.
Yeah, absolutely. We did our tests and everything, and now it seems we have a little hiccup there. We're getting there, ladies and gentlemen. Thank you so much for your patience.
All right, sorry about that. So I'll just start. They're on the way, Frédéric. So my name is Wes Johnson. I'm VP of Software for Cirrus Link Solutions. I've been here for 7 years, was with Arcom and Eurotech previously, working with Arlen on MQTT related projects. Previously there, I was formerly the project lead for Eclipse Cura, and I'm now project lead, as Frédéric said, for the Eclipse Tahoe project, which are Sparkplug implementations, and also the Sparkplug project itself, which handles the TCK and the specification itself. So with regard to Sparkplug development, so I'm going to cover the boring stuff before other people get into the interesting things that are happening with Sparkplug out in industry today. So there are really two different projects at the Eclipse Foundation. The first is the Sparkplug project itself. So it is responsible for really two different things. One is the development of the specification itself, and the other is the development of the TCK, or the Technology Compatibility Kit, which is a way for us to ensure, and also implementers to ensure that their implementation of a project is in fact compatible with Sparkplug. Again, a big part of the purpose of Sparkplug is interoperability between different connected clients to an MQTT server. So clearly, compatibility is important. The other project is Tahoe. So that is really a project around creating compatible implementations. So implementations of various languages, and also those that support the different profiles that are part of the Sparkplug specification. So the ultimate goal of all of this really is to get a official released version of the Sparkplug specification through the Eclipse Foundation. There are, so just go to the second slide there, Frédéric.
Absolutely. Let me switch to presentation mode. Oh.
Thanks. So as part of the release process through the Eclipse Foundation, we have 3 different artifacts that need to go along with that. So one is the specification document itself. The other is the TCK, which is also under the Sparkplug spec project. And then finally, compatible implementation. So once we have all 3 of those different things, then we can officially, under the Eclipse Foundation, release the specification. Can you go to the next slide? Great. So we are seeing presenter view, which...
Oh, okay, yes. Let me... I don't use PowerPoint very often on this particular machine, so let me bring this on the primary monitor. We should be good to go.
Okay, thanks.
Better?
Yeah, better, thanks. All right, so I'm going to cover those 3 different sections. So the specification itself. So the original specification was released by Cirrus Link, along with what was the original Tahoe repo by Cirrus Link to the Eclipse Foundation a few years ago. So that version was version 2.2, and was written in a way that many people probably wouldn't view as very specification-like. It was really geared towards people, towards allowing people to implement it, and in a way that wasn't really technically wordy, which is not perfect for a spec. So with that, a big part of what we're trying to do through the specification project today is to really clean up that language and move towards something that maybe ultimately would become a standard. So with that, we're including normative statements and non-normative statements and making it much clearer and specific around what we meant in that original document. So the new version ultimately will be 3.0. There is a working copy on the link that's there, and I believe we'll be sharing slides, so you don't need to copy that down. Also, we make it available on the Slack channel so you can see the progress as it comes along. So this is a work in progress. And you can see it as it comes along. I'd say we're probably in the 80 to 90% done range. We have a bit more to do, but really all we're trying to do with the specification is really not change the original intent, but we're trying to make the language clearer and make it easier for implementers to implement. All right, next slide. So on the TCK, we're making quite a bit of progress as well. So the TCK is very different from many other TCKs that people might be familiar with. So for example, in the Java world, you'd have a TCK built around an API, and then within the Java language, you would have an implementation, and the TCK would use that implementation as what was being tested. So there are lots of advantages in an environment like that where you're in the same language, you know what the interface needs to be via the API, and it makes it, I wouldn't say easy to test, but the problem is pretty well bounded. In our case, we're testing the way MQTT clients interact within a distributed environment, which is really quite different. The API really becomes the Sparkplug specification itself, and those things that need to be tested within that environment may not be the same language, and it really shouldn't matter, but the problem's quite different. So the way that we're handling this in the TCK is we're borrowing some of the things from the Jakarta TCK in order to make our lives easier. So the specification itself is encoded with annotations that define what are testable assertions that can then be implemented in the TCK itself. So in that screenshot on the left, I know it's probably hard to see, it's basically a coverage report of what the TCK covers in terms of what is specified in the specification that is testable. So we get a report that gets generated as part of the build, so we know exactly what needs to be tested and also exactly what we have covered to date. At this point, we have 149 testable assertions. Again, I think that's probably about 80% of what we ultimately will have. And we have tests for 27 of those right now. At this point, we're really accelerating in terms of the number of tests that are getting implemented, because a big part of this was putting the original framework together to make writing the tests ultimately easier, and in the long term it's going to be far easier to maintain. That right screenshot is a view of the Sparkplug TCK web console. So again, because of the sort of odd nature of how testing needs to take place and the fact that we have different Sparkplug profiles, and so just briefly, a profile is a different type of Sparkplug client. So many of the implementations that have been done by companies to date are edge nodes. But of course, there are host applications as well, which there are multiple implementations of. There are two different flavors of host applications, and also in the specification, we're including a profile for an MQTT server. The original spec stated a 311 compliant server. That's not exactly all that is required, or the only option of what could be required. So we're expanding on that. So those are the four different profiles. So the web console is really there as a tool for implementers to use to test their Sparkplug application, because depending upon the profile, you would only have to pass a subset of the tests. So just a note on some new people that are contributing now. So Ian Craigs from HiveMQ has been very helpful in terms of implementing both framework and tests for the TCK. If all goes well, he'll become a committer on the Sparkplug project next week. Also, Lucas Brand from HiveMQ, he did the web console, and Mitchell McPartland joined, so Lucas and Mitchell are not committers, but both contributing to the projects. All right, next slide. So a quick update on Tahoe. Frédéric, can you go to the next slide?
Absolutely.
Thanks. So Tahoe, a little bit less to report in terms of development here. So again, Tahoe is compatible implementations. Our focus really as part of the release of the Sparkplug specification is going to be the Java implementation. All of the committers on the Tahoe project are from Cirrus Link, and Cirrus Link's commercial products using Sparkplug are implemented in Java. But that's not to say that there aren't others that could be created. So there are some libraries that already exist in Tahoe for C and Python and JavaScript. So as part of the release, we have to have at least one compatible implementation, but there's no reason there couldn't be many more. We're certainly welcoming any additional developers that would like to contribute around any of those other languages, and also around any of the different profiles. So we are in the process of taking some of Cirrus Link's commercial code, and we will be making that available to Tahoe as part of this release process. We've had some requests for getting the Java libraries into Maven Central. So if all goes well, that'll be done next week as well. All right, next slide. So as far as plans from this point forward, so we have a few issues to work out on the specification. We're in sort of that final 20% phase, so things slow down a bit there, but that can happen concurrently with what is happening with the TCK and in Tahoe as well. So also ultimately, there is another body associated with the Sparkplug working group that is the Sparkplug specification committee. Ultimately, that is the group that will approve whether or not what gets produced by the specification project will be able to be released. So we'll be meeting soon to hopefully wrap up some of those final details. With the TCK, really we're at the point where implementing tests is just what needs to be done. The framework's in place, and it's just a matter of getting those knocked out. We probably won't be able to fully automate all of these tests, but honestly, given where we're at this point, I think that we're going to have more coverage than I thought we would have if you had asked me a year ago. So good news there, but there probably will be some manual things that need to be done by implementers to be able to say that they are Sparkplug compatible. So with that, there's also the web console development. So as these tests are developed, there are the corresponding components that exist in the web console as well. For Tahoe, really, given that most of the other pieces of this process are moving along well, the committers on the Tahoe project are going to focus a bit more on that, given that's what's been lagging behind. But there were and are far fewer unknowns around Tahoe. If all goes well, we'll be looking at maybe sometime in Q1 to be at least have the large majority of this in place and hopefully available for people to play around with. But of course, it's all open source, right? So you can go and pull it in now and play around with it today. All right, next slide. All right, so this is a list of resources and how to get involved. So my email's there, the Sparkplug website, as well as all of these projects that I've talked about. Also for general questions, comments, the Slack channels are a really good place to do that. I think that's probably a less antiquated way than using mail lists. But there are many people on there regularly with a lot of expertise in Sparkplug. All right, that's all I have. Now on to the fun stuff from others.
All right. Thank you so much, Wes. Really appreciate the presentation. So now we will bring Dean from Intel for his section about the fantastic wellpad controller they worked on. And so, well, up to you, Dean.
Okay, I'm going to, hopefully you can hear me, Frédéric? Yeah?
Yes, we can hear you. So now let's try to share the slides, and hopefully you're luckier than Wes.
Yeah, let me push the right button. In the test, it pushed the wrong button and strange things happened. It's always safer to share entire screen, right?
Absolutely.
But, oh, there we go. Okay, I had to click something else. Okay, I will be moving to PowerPoint here.
Right.
Presentation mode. Okay.
Excellent.
So you see it in presentation mode? Okay.
Yes.
Yeah. Oh, great. Good morning, good afternoon, good evening, wherever you are. My name is Dean Samara-Rubio, and I am the product line manager in the energy sector at Intel's Industrial Solutions division. We have a group of folks in Intel who work to enable the sale of our silicon through working with end customers and technology providers around the transformation that we see in the energy sector. And transformations in the energy sector, we see, adoption of modern technologies for consolidation of software functions, use of, think about software-defined systems, and developing and integrating some machine learning techniques into automation and control and operations. Myself, I have two primary partners in crime, Vani Desai and Louis DeRoche. And actually, Vani was originally going to give this presentation. She had to leave right now. She's our solution architect and has been working closely and with the Eclipse Foundation on the implementation details and architecture for our Sparkplug bridge implementation. Okay, so I mentioned transformation. So, I think these points are right. Closed proprietary systems to trying to be where you basically an end customer can buy a piece of hardware that they want, and they put it out there in the field, and then they tell integrators and system and software companies, put on that machine what I want, when I want it, how I want it. Let me manage it, or let my proxy integrator or service provider manage it to get the outcome I need. So they don't have to be locked into a long-term contract or a vendor relationship where they are only receiving the functions and capabilities of that one vendor. And this is a big deal. It's a big change for the ecosystem and the market, and it's going to take time, but I think it's where we're going. There's always a talk about, everybody always looks at zero trust, manageability, security, and of course that's a touchy subject in a lot of cases, but it's where things are going, and the industry is moving that direction. And Intel has a major focus on that in our, working on device onboarding, secure measured boot, many technologies for management of systems. Okay, and this is another slide with similar kind of content. What it's trying to say basically is, looking from the left to the right, there's monochrome on the left and in living color on the right. So, there's like in each color representing a different vendor, a different brand, different capability, best of breed technologies being able to be accessed by your end customers. And in this case, when we talk about end customer, we're talking about the original impetus for this program was around oil and gas operations, and in particular gas wells. I mean, you may be aware there's, to get the natural gas from the ground, and the natural gas is a big part of what we're doing in the power utility and energy sector in the world these days, right? Renewable energy comes in, it's not dispatchable. You can't decide when the sun and wind are available. And the biggest resource for balancing that out is natural gas. And so there's been a trend and a movement towards a larger usage of natural gas in the power sector. And it is, part of the support here is to improve the operations and the cost effectiveness of those operations for the suppliers. We talk about this slide is showing basically a lot of things, but let's just maybe you can read this yourself if you have access to the slides afterwards. But there's essentially a computer in the field that has a fairly modern edge software stack, which includes a preemptible kernel real-time Linux, a container environment such as Docker, Podman, etc. And then some middleware that Intel has been focusing on, which is we call the Universal Wellpad Controller middleware, which is this connectivity glue, etc., and some essential services such as a Sparkplug bridge service, which is a bridge from the internal data model and data flows to external world, and I'll talk about that in a moment. And that's the focus of this conversation today. So this is another view of sort of the same thing from left to right: sensors, actuators. There's some field data. Modbus being one of the main protocols, but there's other OPC UA. There's proprietary protocols. There's various different field buses. And there's a bunch of software things going on inside that device, for control, for optimization of the control, for collection of data, audit records, logging, alarms and alerts, filtering, etc. And so the idea is that we want to build that intelligence capability for the edge. But then we want to have an organized and scalable, resilient, standards-based way of moving that data to wherever it needs to go, right? And we put 3 categories of where it needs to go. And those 3 categories would be a cloud service provider systems, whether hybrid or fully in the cloud, for data pipeline, for analytics primarily. There's typically, in all these cases, there's going to be some sort of a SCADA system that is going to be able for operators to get a view of their operations across a range of the fleet of devices they have in service. And then there's going to be enterprise applications, which need, typically we want to have a data lake to bring data in for various different analysis reporting, not necessarily machine learning types of things, but, just basic business operations. I think I would say that, why, so we have experience, and I personally have experience working on a similar type of interface with the OPC UA standard. And I think the Sparkplug standard with the MQTT system, it is working for us. And we're invested in, continuing to move with the Sparkplug specification, Sparkplug bridge service that we have created, based on the Tahoe libraries. This is a little bit more, what this is about is just, it's simple diagram to a little bit more complicated diagram. I basically would say it that way. One thing I would say is that in many of these gas well applications, you're running the control of the gas well. Gas wells, it can be considered to be a fairly simple control function, like a plunger lift, for example, opening and closing a valve based on pressures and pressure differentials, a number of times per day. So you typically would expect a low power operation at the edge. And one of the reasons is that, a lot of these things will be run off of solar panels and lead acid batteries even today. The ruggedization of the hardware is critical. And so class 1, division 2 type of explosion proof certifications are required typically. Sealed devices and then wide temperature range of operation are critical. Okay. I do not have a view of the time. I think I am running a little bit towards the tail end here. Frédéric, if you could just let me know if I need to accelerate.
Yeah, maybe a bit, given we have other speakers.
Okay, so let me try to. So the Sparkplug. So what I want to say here is that the microservice bridges from the internal bus system of our platform. And that bus system is around latency, class of service, microservice to microservice communications. And it's got a lot of flexibility for the user, right, the integrator or the software developer who's going to productize, because we're building a reference design. So things like topics and payloads, definitions inside the device, they're very fungible for the application developer and this integrator to roll out. There's a simple model sort of for, life cycle of communications is generally different than what you have for like a Sparkplug or an OPC UA specification for, like an edge to control room or edge to cloud type of implementation. So there is a need for a bridge. We do not have the Sparkplug specification running natively inside the device. But in the bridge, we handle the major pieces of the contract that you need for the Sparkplug specification: birth, death, data, commands, etc. So there, again, I think these slides will be available for reference.
Yes, we will share them after the fact.
Okay, so one of the things is that we have, again, this internal data sharing bus, which is based on ZeroMQ in the device. And we actually, in this current diagram, I think what I want to just point out is that a data flow to get from a sensor through to a SCADA system has very many steps in it in our implementation today. I think if you look at this blue Sparkplug bridge, and it has an internal MQTT broker, what we're going to do in our evolution is move this Sparkplug bridge service that we've created and connect it here onto the EII bus instead of through a couple layers of abstraction, and that will simplify the chain. Again, it's a work in progress for us. It works as it is now. It just has a little bit more abstraction layers than it really would need to have. And similarly, for a virtual device, like an application to communicate to SCADA, there's a data flow. And then a command to come from the external system, such as the SCADA system, into and so the arrows here are going from right to left. The SCADA system might send a command into the system and how that would propagate through the layers. So those are some flow diagrams for reference. And I'm going to end with this slide. So what are the UWC key ingredients and resources? So first of all, the thing is that what you can learn about how we've been working with other companies on UWC, I'll point you to 2 white papers. One is with ExxonMobil, and this is one of our key collaborators in this program. And then one is with Red Hat, which we're working with them for that scalable, secured total solution, including real-time kernel and manageable system and secure measured boot, et cetera, deployable containers for scale. We have a software hub for Intel, which gives you documentation and some relatively easy to install instructions. And then all of our code is on GitHub, and it's open source with MIT license. So you can see for example, our Sparkplug implementation, I believe it's written in C++. You can see that there. And then we have a Docker registry for some of the containers. More of the containers will be added to the registry as well. These are some of the projects that are involved in the solution. And then a list of hardware devices that you can see which are meeting the expectations of our partner companies, customers, and vendors.
All right. Thank you so much, Dean, for this detailed overview of what you did on the project. It's really exciting, and I certainly invite people to have a look at the white papers and go deeper, certainly learning about this. So now I will leave you, everyone, to Benson and his guests to talk about public water. And so up to you.
I guess I got to click here. Okay. I'm assuming that's working. Can I get a high sign?
Yeah, you're good. We can hear you.
Terrific. All right. So, hello, everyone. My name is Benson Hoagland. I'm with Opto22. I'm responsible for product marketing and strategy here. I've been with Opto for about 27 years, and we're not as well known as Intel or even AWS, who will be presenting after me. So a quick introduction. We're a California-based, privately held manufacturer of industrial automation software and hardware. And, you know, we've got over 4 decades of experience in the field, installed base in the millions, thousands of applications all over the world. Most people know us for mission-critical, USA-made products backed by lifetime warranties. We're also a pioneer, actually, in many innovations that are being used today in industrial automation, including, you know, we're the co-inventor of the solid-state relay, PC-based control. We were actually one of the original founding members and spec writers on the OPC specification back in 1996. And today, of course, we're a strategic member of the Sparkplug B working group with committers and so on. So we're heavily involved in Sparkplug. So let's, here's a quick shot of our manufacturing facility. We indeed are a manufacturer. Everything is made here in the USA, right here in Temecula, California, about an hour north of San Diego. But enough about Opto. Let's focus on what an application looks like with Sparkplug B. And of course, today we're featuring Waterford Department of Public Works. Waterford is founded in 1834, getting its name for 34 regional lakes around the township, located in Oakland County, about 35 miles north of Detroit. And for, as you can see on the screen, water management for Waterford is no small task. There's a lot going on in terms of field devices that are out there controlling water and wastewater for the township. So the legacy system that they had in place was put in the late 90s, early 2000s. And at the time, it was state of the art. And, you know, polling mechanism, traditional type of SCADA infrastructure. But, you know, in today's world, that poses a lot of problems, a lot of issues. You know, while you could put up with some latency and limited bandwidth back in the 90s, today there's no real reason for doing it that way. However, there were some technology things that needed to occur. And of course, that's what we're going to be talking about today. And so their issues were largely getting a better understanding in real time about what was happening throughout this entire township and all of the water and wastewater outlying stations. So these guys attended a webinar, or actually a conference back in the day when we were actually doing conferences face-to-face. And I got an introduction to MQTT and, of course, Sparkplug B. And that was, of course, back in 2018. And these are some of the things that they learned and some of the specific benefits to Waterford relative to their implementation of MQTT and Sparkplug B over the old method. And some of them you're probably aware of if you have any ideas about what Sparkplug B and MQTT are. But I won't read all these to you, but there were some that were really important to them. Obviously, cybersecurity is a critical issue, and the ability to close off ports and all those outstations being secure is a big one. And MQTT and device originating connections become a very important element of that. But of course, the Sparkplug spec defines a binary encapsulation with Google protobufs that dramatically limited how much bandwidth they were using over their cellular network. And this became obviously a big cost factor, but it also became a factor in terms of the bandwidth utilization. So they were able to get immediate responses from the field when anything ever occurred, because again of MQTT and Sparkplug B's report by exception methodology. The pub sub model gave them a lot better bandwidth, a lot better management of those systems as well. And of course, they're creating their tags right down there at the field, right in the, right at the lift stations or at the pump stations. And now those tags get propagated throughout the entire system because of Sparkplug B and the topic namespace definition and so on. And they're moving all these tags directly into an Ignition software application that is running up on AWS. So the new architecture looks like this. They replaced the old RTU radio combination with a new a Groove Epic, a Sparkplug compatible product. And it was essentially another RTU, obviously with a lot more power and capabilities. and deployed all this over a private Verizon cellular network. And then, as I said, they host their MQTT broker on an Ignition platform on AWS. And I'll let Frank talk a little bit more about some of the cool things he's done there. And the other important thing here is everything is TLS encrypted. Not only are we outbound connections and protecting all those assets in the field, but we're also publishing all this data over TLS encrypted and authenticated connections back up to MQTT distributor by Cirrus Link Solutions running on that Ignition platform on AWS. So pretty cool. If you look at the results, sub latency access across the entire system, significantly reduced bandwidth. They never miss anything in the field anymore. They're getting edge status and communication statuses like they never were able to do before. And now they're also using these edge compute platforms like this Epic device to actually do some pretty interesting things right at the edge in terms of, we heard a little bit about it from Intel about doing some, perhaps even machine learning potentially, but all of the controls and everything are done right there. Very quickly, it's not a product demo, but there's a couple of the products that were used in this particular application were the Groove Epic, and in some cases our Groove Rio. And very quickly, Epic is a real-time controller. It's a PLC with all edge gateway features, an I/O system, a built-in HMI. It is Class 1 Div 2 ATEX -20 to 70. I mean, it's essentially an edge computer that is dressed down like an RTU. So very industrial device. But at the outset, from the moment this device was put on the market in 2018, it came with Sparkplug embedded. So all the tags, everything from the device is published out via Sparkplug B. And the same goes for our Rio, just a remote Ethernet I/O software configurable device. Same idea, everything Sparkplug B. So with that, I'm going to have first Frank Fisher. Welcome, Frank. Thanks for joining us from Waterford. Frank is the engineering superintendent for Waterford DPW. And followed by that, we'll hear from Kevin Finkler from Controls. And Kevin, of course, was the system integrator that put this together. Kevin's the software engineer. He's the one that actually made all the pieces work. So Frank, if you have a few words that you'd like to share, now's your time.
Yeah. All right. Thanks. Thanks, Benson. Yeah, I mean, actually, you explained it really well in a few minutes. What would probably take me like an hour to kind of go through in this whole thing. But just to kind of give you the overview from the public works point of view, we started a big project like 2017 to replace our aging SCADA system. And right in 2000, we were just 5-6 months into it, into the planning stage, and just starting to roll it out. And that's when in 2018, Opto released the Epic controller, and me and the DPW director at the time went to Chicago just to see it. And it really changed our whole direction. This was a big project for us, 90 some sites altogether. And we kind of already committed to go down a certain road. But when we saw the possibilities with MQTT, and specifically, in this case with the Sparkplug protocol, it really changed our whole outlook on it. So what we ended up doing was coming back to the office, and we talked the whole drive back, about 5-6 hour drive, about how this would impact our plans. And we went through and we spent our due diligence going through everything, and couldn't believe that it was really possible what we would be able to do with this. But going through, we started testing. We got a couple controllers to test, and then we decided to try a couple of stations with it, and it worked great. And the biggest thing for us is we had a polling program that would take 4 or 5 minutes to pull through all of our sites. Well, with MQTT, we're instantly getting that data back, with our cell modems. So the big advantage to us is we had sites that we needed data back from. There was hardly any change. It was a really low flow site. We might not get any data for an hour, but still we're polling it all the time. What this allowed us to do is, other than the small heartbeat that goes to make sure that the connection is still there, it's not passing data unless something changes. So that was huge for us. And it still amazes us when data comes in instantaneously. It's just, you're so used to that polling protocol. But yeah, really, that's really what I wanted to say about a lot of this is the benefits, and we're still trying to figure out what else we can do with this. We have a lot of other instrumentation that we want to be able to pull data in from out in the field, and wasn't really feasible before. Well, now we're looking at ways to put it in at more edge of our network, not just at our lift stations and our treatment plants, but throughout the whole organization. Where can we use it with flow meters? Where can we use it, throughout all of our assets, and to give us a better overview. So we're just beginning that journey. And just to give you a quick update, we've got 90 sites total. Our complete water system, or our sewer system, is completely done. We're at 68 sewer lift stations that are now on MQTT. Where the water side, there's more programming and config, and we're about halfway done with that. So we're looking by the end of 2022 to be completely onto MQTT with our whole infrastructure. So with that, I'll kind of pass it along to, I think Kevin's going to be next talking.
Yep. Can you guys hear me all right?
Yeah.
All right. So yeah, this was my first time using MQTT on such a wide scale, and it was really interesting getting everything all set up. But yeah, like Frank mentioned, the biggest upside to all of this was the super low latency that the MQTT protocol uses. And like you said, that we were running a polling scheme on the controllers before, and one station could completely run in the entire time it would take from polling and then loop all the way back around. And by the time it got back to it again, the station would have run, and you could have potentially missed out on some data there. So the whole report by exception way of handling the data, it was definitely helped out a lot with this. But so yeah.
Great, thanks. Thanks, Kevin, and thanks, Frank, for joining us today and sharing your experiences with MQTT and Sparkplug B. We have a lot of other customers who are doing the same thing. Not everybody wants to talk about it like these guys, but we appreciate that dearly. And with that, we'll pass it back over to you, Frédéric. Unless we have any questions, obviously we're happy to take questions.
So it seems there are no questions in the chat, at least. If you have any, please use the ask a question feature of the platform, or put them in the chat, and maybe we can revisit the topic at the end. In any case, Benson, what really strikes me is how easy it seems to have been, working on this project with the help of the technology. So what were, the pitfalls or the issues you didn't anticipate that occurred when you worked on this project?
So, the biggest challenge for using, this new technology, and it's really not that new, let's be honest. MQTT was developed to solve a SCADA problem in the late 90s. So, when we say it's new, it's just because the awareness is probably new. But the biggest challenge, honestly, is I think a lot of people are particularly in SCADA, a lot of people are very used to the idea that they need to reach out to devices and poll them for their status before they can do anything else. And that is a directly coupled one-to-one connection, something that many in the SCADA industry are frankly very familiar with. So when you turn that model upside down and say, hang on, how about the devices in the field let SCADA know when they have a change? That's a little bit difficult for people to understand, at least at first. But once you see it in action and you're not giving up performance, you're actually gaining a whole bunch of benefits, then the lights kind of go on. But it's been a new territory. So that's probably the biggest challenge from a system integrator and even from an end customer. Clearly, Frank saw it immediately. I mean, as soon as he saw how the pieces work together and knew the problems that he was trying to address in the field relative to latency and bandwidth, it was a no-brainer. So, that's probably the biggest challenge that we're seeing.
All right, that makes sense. And so in a way, it's a paradigm shift, and Sparkplug is the clutch that you need in order to do it properly. Absolutely,
and it's one of the reasons why we, from a vendor perspective, quite frankly, are all in. We invented OPC, but we're all in on MQTT and Sparkplug B. So thanks for the opportunity to share our story.
Well, of course, thank you. And some people were asking about the video for the webinar being available. So you'll be able to rewatch on Crowdcast after the fact, and we'll publish this on the YouTube channel of the Eclipse Foundation later today, or by tomorrow it should be up. So stay tuned for that. So thank you for sharing this, Benson. And now up to you, Arlen, whenever you are ready.
All right. Oops, get this out of the way. All right, I'm assuming everybody can see my screen okay?
Yep.
All right. So this, Poogle and I will try to be very quick here. We may run a bit over. If we do, we'll go ahead and record that and then make it available. So what we're going to talk about here is what Poogle and I have been working on in using Sparkplug to connect to a new service that Amazon has. So again, my name's Arlen Nipper. I'm the president and CTO of Cirrus Link. And with me, I've got Poogle. And Poogle, I'll advance the slides here as you kind of go through what you were trying to accomplish from an AWS standpoint.
Sure. Thanks, Arlen. This is a pre-built solution offering we launched last year, jointly working with partners like Cirrus Link Inductive Automation. Because one of the biggest asks from customers are, we have multiple IoT AI/ML services. How do we bring this together to accelerate their journey around Industry 4 adoption? That's all this is around. If you go to the next slide, Arlen. Awesome. Again, what Amazon is trying to do is drive this data-driven insights based on two largest sources of machine-generated data. One is from the factory floor, which is pretty much a brownfield environment with existing PLC SCADA devices. I think people are having a tough time hearing me. Maybe I'll increase my volume. Hopefully this is better. So this is around driving data-driven insights from two largest machine-generated data. Again, having said that, so the services we have launched, solutions we have launched, gets the data from both manufacturing plants and as well as the connected products to make that happen and streamline various processes of enterprise. If you go to the next slide, Arlen. Yeah. Again, these are the various numbers which comes from our multiple partners and analyst organization we work with. Anything from 30 to 40% improvement in manufacturing efficiency if you perform the data-driven insights by leveraging various capabilities, whether it is having the asset model in place for doing RCA near real time or AI/ML-based inferencing. So again, in that context, customers are trying to get to these Industry 4.0 value proposition. If you go to the next slide. If you go to the next slide, yeah, thanks. So again, achieving this is not that easy because of various challenges in the plant floor, because we are dealing with brownfield environment where you need to know how to talk to the existing PLC SCADA devices for our Amazon services. Same thing goes for multiple protocols out there. There are literally hundreds of protocols with which machines talk to each other. So these are the challenges customers went through. So they asked for a pre-built offering, which we did, based on our service called as Sitewise. If you go to the next slide, Arlen. This Sitewise service helps in modeling the asset accurately and to get the data into the cloud, so you can drive your AI/ML and various other inferencing. So with that, I'll hand it over to Arlen.
Okay, thanks, Poogle. So again, to Poogle's point, we've been working with very large customers with MQTT Sparkplug and our injector modules for the last probably 4 or 5 years. And what we figured out is that throwing a bunch of measurements into a data lake does not solve a problem. It just moves the problem from the plant floor to the cloud. And so if we look at this model that Sitewise, we can build a model in the cloud instantiate that to create an asset, and the asset has our measurements. And now we've got data organized so that when data analysts come and look at that, they can figure out what in the heck is coming from the plant floor or the remote site, like the Intel project. So real quickly, let's at a very high level, what does Sparkplug do for us from that context? So number one, a OT-centric topic namespace gives us plug-and-play auto-discovery. Let's not go into all of the verbs and all of the states. Let's just say that, hey, if I've got a namespace, I can subscribe to it, and now I can start figuring stuff out. Number two is that we can now publish a model from the edge. Now, when we first started on Sparkplug, we were all focused on a single source of truth for measurements, for process variables, for a pressure or a temperature. But what we quickly figured out is that we needed to be able to define the model first, instantiate that, and then worry about the measurements and the process variables. Third thing Sparkplug does is it gives us a binary encoded, so very efficient, process variable object with everything we need to know. So when we go find that object, we know the name, the value, the timestamp, the data types, engineering units, ranges. And then lastly, Sparkplug helps us define that nebulous aspect that nobody ever read in the MQTT spec of why did Andy and I put the last will and testament. Well, if we properly manage that, it lets us do report by exception, bidirectional command and control, and store and forward. So if we take that and look at it from the standpoint, if I can publish a model from the edge into IoT Core, which is an MQTT broker in Amazon, and then provide a very simple service that we call IoT Bridge that Cirrus Link developed, that means on the left, I can see models being published, and on the right, I can look into AWS Sitewise and build those models, create those assets, and populate the time series database in there real time, very efficiently using report by exception. And Poogle and I need to be able to do this in a day. We need to be able to engage your customer, find a piece of equipment, model it, and get that model into Sitewise without having to hire an army of consultants to be able to do that. So that's kind of the story of how we use Sparkplug and a service from Amazon called Sitewise to build models very quickly. So with that, I'm going to hand it back over to you, Frédéric.
All right. Thank you so much, Alan.
That was my 10-minute synopsis.
Yeah, well, I'm surprised we made it exactly in time for the closing time of the webinar. In any case, what's really fascinating in what you just discussed, Alan, is that although, I mean, the base AWS platform doesn't necessarily have everything in MQTT support to support Sparkplug. You are able to come up with an offering that enables you to go just there and then have the benefits of what AWS offers on the cloud side, while having the flexibility that you need on the client side on your devices and all. So that's
right.
quite impressive.
Well, it was a perfect kind of marriage between a service that operates on a model, but without having to have 11 different stages where you create that model. Let's use tools on platforms, create it. Let's use Sparkplug to publish it. Let's use Sitewise to consume it.
And that's probably the best of both worlds in that perspective.
Yep.
Excellent. Well, thank you, Poogle and Alan, for this presentation. If there are no further questions in the chat for any of our speakers, now will be the time probably to close this call. In any case, we'll have other events this fall. So if you want to stay in touch, please, as Wes invited you to at the start of the call, join our Slack workspace or our mailing lists if you prefer that format. And obviously, don't hesitate to reach out if you have any questions or comments about what we did. I appreciate your patience with us at the beginning. Somehow our audio and screen sharing tests somehow they weren't comprehensive enough for whatever reason. But in any case, I appreciate that you stayed till the end, and certainly look forward to see you again in a future event. So to our speakers, once again, a big thank you. I really appreciate your contributions today. And to the audience, we've got maybe a question or two there. Let me check. So from Christopher, we have a question. So you are saying that if someone has a device like, say, an Opto22 Groove that speaks Sparkplug, then you could pipe that data right into Amazon Sitewise without additional plugins, gateways, and translators. So maybe a question for you, Arlen.
Yes, that is correct.
Okay, simple enough. And Kudzai is asking if there's a possibility to have Sitewise Bridge as a managed service instead of EC2.
We're working with Amazon on that right now.
Exciting. So stay tuned then for an announcement. Looking forward to this. All right. If there are no further questions, once again, thank you.
Thanks, everybody.
See you next time.
All right.